All right, let's get into it. If you're an engineer, you know that heart-stopping feeling when the pager goes off at 3 a.m. because production is down. In this explainer, we're going to talk about how to turn those nightmare scenarios into something you can actually survive, maybe even predict. We're pulling lessons from the playbooks of giants like Netflix and Google to see how they build systems that don't just survive failure, they bounce back from it. So the very first thing we have to accept right out of the gate is this core truth. You cannot, I repeat, cannot build a system that never fails. It's impossible. Servers crash, APIs you depend on will time out, networks will get flaky. It's never a question of if it's going to happen. It's just a matter of when. And anyone who's ever been on call knows this deep in their bones. And that leads us to the big question, the one that really changes the whole game. If shooting for 100% uptime is a fool's errand, then what's the actual goal? The answer isn't about preventing failure anymore. It's about building a system that expects failure and knows exactly how to handle it. Which brings us to our key word for today, resilience. You know, it's not about never getting knocked down. It's all about how fast you get back up. The goal isn't no failure. The goal is no surprises. The most robust systems out there are actually designed to fail in predictable ways and then recover all on their own. Okay, so let's perform an autopsy on an outage. You might think that most of them are caused by some super exotic once-in-a-lifetime bug, right? But the truth is, way more often than not, the call is coming from inside the house. They're self-inflicted wounds caused by some surprisingly normal, everyday activities. Just look at this list. Does any of this ring a bell? That config change someone pushed at 5 p.m. on a Friday? A new deployment that accidentally torpedoed a service you didn't even realize you were connected to? Or heck, even just your database growing so big that the assumptions you made a year ago are now totally wrong? These are the usual suspects that bring good systems to their knees. Let me tell you a quick story. There was this huge global website, and its entire session management system relied on one single cache. Now, that's a pretty common setup, but it also created this massive single point of failure just waiting for a bad day. And one day, that bad day came. For a totally routine maintenance reason, that cache node restarted. Just a simple reboot, something that should be no big deal. But because everything depended on it, the result was absolutely catastrophic. Millions of users all over the world were instantly logged out. Every shopping cart, every active session, just gone in a flash. It's a perfect and painful example of how one tiny, fragile component can bring down an entire global platform. And here's another classic horror story, the retry storm. It starts out so innocently. A single service starts to get a little slow, so the other services that talk to it, trying to be helpful, they just start hammering it with retry attempts. But all that does is multiply the load on the service that's already struggling, which makes it even slower, which triggers even more retries. And before you know it, you've got a full-blown cascading failure that takes down the whole system. Okay, enough of the scary stories. Let's talk about solutions. It's time to build up our defenses. The best way to think about resilience isn't as one giant wall, but as multiple layers of armor, where each layer is designed to stop a different kind of attack. And the absolute non-negotiable foundation for all of this is observability. You have to see what's going on inside your system. And I'm not just talking about a CPU graph. I'm talking about rich metrics, structured logs, and distributed traces that let you follow a single user's request as it jumps across a dozen different services. Without that vision, you're flying blind in a hurricane. So remember that retry storm we just talked about? How do we stop it? Well, you fight it with intelligent back pressure. Instead of retrying instantly, you use exponential back-off, waiting a bit longer after each failed attempt. You add jitter, a little bit of randomness, so all your servers aren't retrying at the exact same microsecond. And most importantly, you use circuit breakers. They're like a fuse that blows, stopping requests to a failing service to give it a chance to breathe and recover. Sometimes the most resilient thing you can do is just stop. And this is that whole idea of defense in depth. Each one of these strategies is another layer of armor. Rate limiting is your shield against a flood of traffic. Graceful degradation means that if the recommended for you feature breaks, your users can still, buy things. Timeouts and bulkheads act like watertight compartments on a ship. They contain a failure in one area so it doesn't sink the whole vessel. All right, now for a total change of pace. Everything we've talked about so far has been defensive. But what if the best defense is a really good offense? This is where we get into the powerful and, let's be honest, slightly terrifying idea of chaos engineering. This is the mantra of chaos engineering right here. Companies like Netflix basically invented this idea. They have tools that deliberately and randomly shut down servers in their live production environment. The goal is to find your system's weaknesses before your customers do by intentionally causing failures, but in a controlled and deliberate way. I mean, this really says it all, doesn't it? Which scenario would you rather be in? An unexpected, uncontrolled failure in the middle of the night that's actively affecting your customers, or a planned, controlled experiment run on a Tuesday morning when the whole team is online, caffeinated, and ready to observe and learn? It's a no-brainer. Which brings us to our final and maybe most critical layer of resilience. This one isn't about code or servers. It's about the people. It's about the culture you build in your organization. This quote is such a powerful way to think about failure. Yes, an outage is painful, but it is also an incredibly valuable learning opportunity. Think about it. You just got a free, full-scale stress test of your entire system and your team's response. The absolute worst thing you can do is just fix the immediate problem and then try to forget it ever happened. The way you learn from an outage is by running a blameless postmortem. The key word there is blameless. The focus is never, ever on who made a mistake. It's on what part of the system allowed that mistake to cause an impact. You ask these questions. What technically broke? Why didn't our alarms or our tests catch this? And what are the concrete things we're going to do to make sure this class of problem can't happen again? Because ultimately, this is a team sport. Resilient systems are not built by lone geniuses. They're built by teams that share knowledge, that write down how things work in runbooks, that practice for failure with game days, and that review what went wrong without pointing fingers. It's all about the culture. So, as we wrap up here, it really all comes down to this classic engineering motto. You always hope for the best, but you design, architect, and build for the worst, because outages are going to happen. Panic, on the other hand, is optional. And that leaves us with one last thing for you to think about. Looking at your own systems, what's that one single point of failure you've been kind of ignoring? What's the one thing that, if it went down tomorrow, would cause the most chaos? What's the very first failure you're going to start preparing for?